Hi everyone, today we are going to learn how to solve square root equations. Our essential question is, what are the different methods that can be used to solve square root equations? So let's start with this example here. Square root of x minus 1 equal to 3. We're trying to solve this using table and graph. So the first thing that I'm going to do here is to enter this equation into my calculator. How? By taking the left side and entering this as y1 into calculator and the right side as y2 into calculator. So I'm going to go to my calculator, y equal to, and I have already done that, square root of x minus 1 for y1 and 3 for y2. In order to solve this with table, I'm going to use a second graph which has table on top of that, and it's going to give me the table. Three columns. One is for x, next one is for y1 and y2. So the solution of this equation is the row that on that row for 1x, both y1 and y2 are equal. This one, the first row here, for x equal to 1, y1 is 0, y2 is 3. So this is not a solution. This one also, x equal to 2, y1 is 1, y2 is 3. And the same for all the others, except the last one, on this one here, x equal to 10, y1 and y2 are both 3. So this is the solution of my equation. So I'm going to write that in the table here, and I'm just going to write the ones that have integer numbers for y1 just because it's easier. So x is 1, 2, 3, and I'm sorry, this one was 5, 2, 5, and the last one was 10. These values of x gave me integer values for y, for y1, 0, for 2 it was 1, for 5 it was 2, and for 10 it was 3. And y2 was always equal to 3 because the equation is just y equal to 3. So the solution is this row over here because y1 and y2 are equal to each other. So I'm going to say x equal to 10 is the solution of this equation, x equal to 10. And how do I solve it graphically? I'm going to graph y1 and y2 here. y2 is equal to 3. So we know that if we have an equation like y equal to a number like 3, the graph of this line is just a horizontal line that is passing through y equal to 3. So the graph of y2 is just this line passing through y equal to 3. And y1, let's graph these points. X equal to 1, y is 0, 2 is 1, 5 is 2, and for 10 it's 3. So I can graph it, and here I'm going to see that at this point these two graphs are crossing each other. The solution of this equation is the point that the two graphs are crossing each other. Basically, the intersection of two graphs, y1 and y2, is the answer. At this point, x is equal to 10, and y for both y1 and y2 is 3. So that's my solution. I can also see that on calculator. You see, if I go to my calculator graph, and I will see that, let me make the window a little bit bigger. Okay, so I changed my window from 0 to 15, -2 to 10, so I can see this part of graph as well. And this point is the intersection of these two graphs. This one is y2, which is y equal to 3, and this one is graph of y equal to square root of x minus 1. So the intersection point, which is here, is the solution of this equation. How do I find the intersection? Go to second, trace, and number 5 gives you the intersection. So I go number 5, then you need to hit the enter for 3 times. First curve, enter, second curve, enter, and your guess, just enter, and it's going to go to the intersection point, and it will give you x equal to 10. So it's the same thing that we found here. So that's how you use your calculator to find the intersection point. Now let's go to the next part. Here we are trying to solve the equation algebraically. The first step to solve the equation algebraically is to get the radical by itself. It means when you are given a radical equation, you will need to have the radical on one side and everything else on the other side. And the second step is to square both sides. So let's practice this one. This is the same equation that we got on top. So the first step here is already done because the radical is on one side by itself, okay, and everything else, which is 3, on the other side. So the first step is already done, and the second step is to square both sides. That means raise both sides to the power of 2. Why am I doing this? The reason is that we want to solve this equation for x, but this x is stuck under radical. So I need to get rid of the radical. This radical is, you know that if you don't see any index, that means the index is 2. This is square root. In order to undo a square root, you need to raise that radical or square root to the power of 2. Why is this happening? Let me give you this example. Let's say I have square root of a, and I'm going to raise that to the power of 2. What happens? This is square root of a times itself, yes, because it's power of 2. And if I multiply these two, I'm going to write just 1 square root and multiply, this was a, I'm sorry, a times a, which is a squared. So now I have one radical, and under the radical I have a squared. So this means I have a group of 2. A squared is a times a, group of 2, and I can move it to the front of the radical. So take it outside of the radical. So it's just going to be 1a. So as you see, square root of 2 to the power of 2 is equal to a. That means this power basically cancels this radical and is equal to a. Anyway, so I raise both sides to the power of 2, and in this way I can cancel the radical here. On the left side I will have x minus 1, and on the right side I have 3 squared, which is 9. Now I have just a simple linear equation, and I can easily solve that by adding 1 to both sides. So after this step, x is equal to 10, and I found my answer. And it's the same thing that we got here. So let's go to next example here. Square root of 2x minus 1 plus 3 equal to 0. So the first step is to have the radical by itself on one side. That means I need to get rid of this 3. To get rid of that, I subtract 3 from both sides. On the left side, I will have square root of 2x minus 1, and on the right side, I have negative 3. The next step is to raise both sides to the power of 2. So this power of 2 will cancel square root, and I will have 2x minus 1 equal to negative 3 squared, which is 9. Now again, I have a linear equation. I'm going to solve that by adding 1 to both sides. So it will be 2x equal to 10. Then divide both sides by 2. So these two cancel each other. And then we have x is equal to 5. So at this point, it looks like I have the answer. X equal to 5 is a solution. But here's the point. We need to be sure to check for extraneous solution. What is extraneous solution? Extraneous solution is a solution that emerges from solving the process of solving an equation, but basically it's not a valid solution to the equation. So how do I know if it's an extraneous solution or not? I'm just going to plug this value, x equal to 5, into my equation and see if both sides are equal to each other or not. So here I have 2x minus 1 plus 3 equal to 0. I'm going to plug x equal to 5 here. 2 times 5 minus 1 plus 3. It should be equal to 0. 2 times 5 is 10. Minus 1 is 9. So square root of 9 plus 3. Square root of 9 is 3 plus 3. It's 6. And as you see, it's not equal to 0. That means this is not a solution. So where does this come from? The issue comes from here. As you see at this point, I have square root of 2x minus 1 equal to negative 3. And that's something which is not possible. We know that a square root can not be equal to a negative number. So because square root cannot be equal to a negative number, that's why when I solve this and I get 5, that 5 is not a valid solution. It's an extraneous solution. So I could basically stop at this point and say because 2x minus 1, square root of x minus 1 cannot be a negative number, so basically we don't have any solution. Okay, so let's go to the next problem. Here we have 4 times square root of 3x minus 8 plus 1 equal to 13. So my goal is to have this radical, this one, by itself on one side. That means I need to get rid of 4 and 1. Which one should I get rid first? 1. Because according to PEMDAS, I mean basically inverse of PEMDAS, I'm going to use inverse of that, the other way of that, because we are trying to undo 1 and 4. I'll see that subtraction and addition are prior to division and multiplication. So that means I need to get rid of this 1 first. So I subtract 1 from both sides. This will be 4 square root of 3x minus 8 equal to 12. Then I'm going to divide both sides by 4. These two cancel each other, and it will be 3x minus 8 equal to 12 divided by 4 is 3. Now I have a radical on one side and everything else on the other side. This is where I'm going to raise both sides to the power of 2, because at this point I can get rid of this radical now. So these two cancel each other, and it will be 3x minus 8 equal to 3 squared, which is 9. Now solve for x. Add 8 to both sides. Again, according to the same thing that I just said here, we're going to get rid of 8 first. So this will be 3x equal to 17, and from here x will be 17 over 3 because we have divided both sides by 3. So it looks like this is my answer. Now I just need to plug that here and try it into my equation and see if that's a valid answer or not. So into this equation, I'm going to write that with green color. It's 4 times 3 square root of 3. Instead of x, I'm going to write 17 over 3 minus 8. And then we have plus 1. This whole thing should be equal to 13. Let's see if that's right or not. So 3 times 17 over 3. This 3 on top and this one in the bottom cancel each other. And here I will have 17 minus 8. 17 minus 8 is 9. So basically I have 4 square root of 17 minus 8, which is 9, plus 1. Square root of 9 is 3. So this is 4 times 3 plus 1. should be equal to 3. Let's see. 4 times 3 is 12, plus 1 is 3. I'm sorry, it's 13. So both sides are equal to 13. So that means this is a correct answer. It's a solution. Okay, let's go to next example here. Square root of x plus 3 equal to square root of 2x minus 1. Here I already have one radical on this side and another radical on the other side. So basically I can say the first step is already done here. We have radicals by themselves on each side. So I'm going to go to the next step. Raise both sides to the power of 2 because I want to get rid of the radicals and solve for x. So there's this radical with this one cancel each other. This one also with this one. So it's x plus 3 equal to 2x minus 1. Now I just have a simple linear function. I can solve this for x. Subtract x from both sides because I want to have all the x's on one side. So this will be 3 on left side, 2x minus x is x minus 1. Then just add 1 to each side. And I will have x equal to 4. So x equal to 4 is my answer. This is my solution. Let's try that into the original equation and make sure it's not an extraneous solution. So the left side, instead of x, I write 4 plus 3. And on the right side, square root of 2 times 4 minus 1. So the left side 4 plus 3 is 7, square root of 7. The right side 2 times 4, 8 minus 1, again, it's 7. So two sides are equal, that means this is a solution. Okay, let's go to the next example. Again here, both sides are radicals. So let me erase here. Okay, so we have one radical on each side. I'm just going to simply raise both sides to the power of 2. They will cancel the radicals, and I will have x plus 1 on one side and 2x minus 8 on the other side. Again, just simply subtract x from both sides, and 1 equal to x minus 8, and then I'm going to add 8 because I want to have the x by itself on one side, and it will be x equal to 9. Okay, now let's try and into the original equation and make sure it's the right one. I'm going to try that here. Square root of x equal to 9, plug that here, 9 plus 1. And here, 2 times 9, instead of x, write 9 minus 8. Okay, to the left side, square root of 10. The right side will be also 2 times 9, 18, minus 8, again 10. So they are equal, and that means this is the right answer. Okay, so here we have the list of all the steps to completely solve a radical equation. First one, isolate the radical term. That means have the radical by itself on one side. Next, raise to the appropriate power. What do I mean by raising to the appropriate power? That means if I have a radical like this, we know that the index is 2. So the appropriate power will be power of 2 because this will cancel this radical. And if I had a radical like this one that has index of 3, the appropriate power, in order to undo this radical with index 3 or third root, is going to be 3. So if you raise that to the power of 3, they will cancel each other. So that's what we mean by appropriate power. Well, after raising to the power and canceling the radicals, we're going to just simply solve for x, and the last step is to check your answer. You need to look for extraneous solutions. So Let's try another example here. I'm going to do this using a calculator. So how do I solve that? Again, the left side as y1 and the right side as y. Okay, so this is my calculator. I go to y equal to, I have already done that. Y1 is equal to square root of x plus 1. That's the left side, and the right side, y2 equal to x. Now, if I um, graph them, this is the graph of my equations. What is the solution? The solution is this point, which is the intersection of these two graphs. So I need to find that. So I'm going to go to second, trace, and number 5. Then you need to hit the enter for 3 times. First curve, enter. Second curve, just enter. It will automatically go to the next curve. And then what is your guess? Again, it's going to automatically go there. And it's going to give me the intersection, which is 1.61. So x is equal to 1.61. And there was another, yes, 1/8. I'm just going to write the 3 decimal numbers. So that's my answer. Let's go to the next example here. We have square root of 2x plus 14 equal to x plus 3. So let's try this one algebraically, okay? So we already have the first step done again because the radical form is on one side. It's already isolated. So I'm going to go to next step, which is raising to the power of 2 because the index here is 2. And these two cancel each other. And I will have 2x plus 14 equal to, this one was raised to the power of 2. So it's going to be x plus 3 to the power of 2. Now, I'm not going to write this in this way here. I'm going to expand x plus 3 squared. That means x plus 3 squared is basically x plus 3 times itself. Okay. Now I'm just going to FOIL that. X times x squared, x times 3, 3x, 3 times x, and 3 times 3, which is 9. Then combine the like terms, 3x and 3x. It will be x squared plus 6x plus 9. So the right side is x squared plus 6x plus 9. Now, in order to solve this, I have a linear on the left side and a quadratic function on the right side. I'm going to change this equation in a way that I have only one quadratic function. So I can factor that, and that way I can easily solve the equation. So what I do here is to subtract 2x from both sides. Okay, let me write that a little bit like here. So 2x and negative 2x cancel each other, and 6x and 2x will be 4x. So on the left side, we have positive 14, which I don't really need to write the positive, just write 14 because it's just one number here, equal to x squared. 6x and minus 2x is positive 4x plus 9. Next, I'm going to subtract 14. So I will have x squared plus 4x minus 5 equal to 0. You see, 14 and negative 14 is 0. So what happened here? I have a quadratic function. I can easily solve this by factoring that. So use the big X here. Two numbers that if you add them, you get 4, and if you multiply them, you get negative 5. What are those two numbers? They are 5 and negative 1. So this is equal to x plus 5 times x minus 1 equal to 0. Now it's very easy for me to solve this for x. If you have a quadratic function in the factored form, just set each factor equal to 0. X plus 5 equal to 0. So from here, x equal to negative 5. And then x minus 1 equal to 0. And from here, x is equal to 1. Okay, so these are my solutions at this point. I just need to make sure they are not extraneous solutions. Make sure they are valid answers. So I'm going to plug them here. X equal to negative 5. I am going to plug that here. It will be 2 times negative 5 plus 14. And the right side is negative 5 plus 3. Okay, so the right side is negative 2 and the left side, 2 times negative 5 is negative 10 plus 14 will be 4. Okay, so square root of 4 is 2 and on the right side we have negative 2. So that means this is not a solution. So this one is not a solution. How about the other one? Let's write that here. X equal to 1. Let's plug that into the original equation. 2 times 1 plus 14. That's the left side. And the right side is x plus 3. That means 1 plus 3. So left side, 2 times 1 is 2 plus 14 is 16. 1 plus 3 is 4. Square root of 16 is 4. And the right side is also equal to 4. So this one is good. This is a solution to our equation. Okay, let's go to the next example here. We have negative 2 square root of x minus 2 equal to 3. I'm going to solve this again with a calculator first, and also I will solve that algebraically to see how each of them would work. So I'm going to enter first one, left side as y1, right side as okay, so in our calculator we entered the two sides of the equation, y1 as the left side and y2 as the right side. Now let's graph it and find the intersection. As I graph it, I will see that the two lines are not going to intersect each other. They will never cross each other. So if there is no intersection, that means there is no, no intersection means there is no real solution. Okay, so we graph the functions, and I noticed that in the graph, the two graphs are not going to cross each other. That means there's no solution. Now let's solve this algebraically. So I have negative 2 times x minus 2 equal to 3. The first step was to have the radical by itself. So I'm going to divide both sides by negative 2. Okay, and it will be square root of x minus 2 equal to negative 3 over 2. You see, I just brought this negative to the front, so it's negative 3 over 2. And guess what? Here we have square root equal to a negative number. And we know that this is not possible. A square root cannot be negative. So again, there is no solution here. So in both cases, we figured out that we cannot have any solution. Now let's try the next one. Again, I'm going to solve this graphically. So this one to y1, this one into y2. Okay, so as you see, I already did that for you, and we have square root of negative 15 plus 8x. As you see, the equation was m, but we don't have m in our calculator, so instead of m, I just used this variable x. So that's the left side, and the right side was just m, and I entered x here. Now I'm going to graph that. Okay, as you see, this is my graph, and it looks like we are going to have two solutions because the graphs are going to cross each other at this point here and also somewhere around this point. So let's find the intersections. We go to second, trace, and number 5. So just hit the enter for 3 times. First curve, and then second curve, and what is your guess? It's already almost on the intersection point, so just enter. It's going to give us 5. So the first answer is x equal to 5. And the next one, we want to find this intersection. Again, second, trace, number 5. First curve just automatically will go on the curves. And for the guess, I'm going to move this to this side, like closer to my point. Because we had 2 points, I'm going to move this one closer to the other intersection, so I will have that. Then enter, and it's going to give me x equal to 3. So these are the solutions. And now I'm going to plug those into the equation and make sure they are valid answers. So for x equal to 5, just plug that into equation. It will be negative 15 plus 8. Instead of m here, I'm going to write this solution 5. It should be equal to m itself, which is 5 in this case. Okay. And x times, 8 times 5 is 40, minus 15 will be 25. Should be equal to 5. Square root of 25 is 5, and it's equal to 5. So this one is okay. Now the next one, x equal to 3. It will be negative 15 plus 8 times 3 should be equal to m, which is 3 in this case. Okay, so 8 times 3 is 24, minus 15 is 9, so square root of 9, which is 3, and it's equal to 3. So this one is also a valid answer. So these are the solutions. So this was today's lesson, and I hope it was helpful for you. Have a great day.